When you receive a file over the internet, how do you ensure that the file is not corrupt? And how do you ensure that the file has been sent by an authentic user and not by an imposter? Or how can we ensure the passwords stored in a database are safe from the prying eyes? Or how do we manage to store a lot of data in a neatly designated buckets? Hashing helps us to address these problems. In this and the subsequent videos, we will learn about the concept of hashing and get to know about the characteristics of a hash function, which helps in selecting an appropriate hash function based on our needs. Then we will learn about different areas of its application and some commonly used hash algorithms. Then we will implement a simple hash function, and while implementing the same, we'll understand the concept and importance of collision. And finally, as a coding example, we'll implement a hash table and understand its advantages and disadvantages. Let's get started. Hashing is a process of converting an input value of any type, any size, and any length to a unique fixed length value called hash value. These are also known as digest, hash codes, or hashes. So, as a process, it has three parts in it. First is input data. It could be text or binary data of any length. Second is the hash function, which works on the input data and generates the hash value. The third part is the hash value. It is a fixed length output of a hash function, shown in hexadecimal format. Here is one example. In this, we are using a hash function MD5, which gives a fixed size output of 128-bit hash value. These 128 bits equal 16 bytes, which is represented in 32 hexadecimal characters. One way or non reversible, which means if we know the hash value, it should not be possible to compute the actual input. We can associate this characteristic with the challenge of saving a password in a database. Once a password is saved as a hash value, it will not be possible to guess the original password text. Deterministic. It means for a given input, a hash function must generate the same hash value for any number of times. This makes it consistent and predictable. Continuing with the database example, when a user types in the password, the hash function will generate the same hash value and allows a user to log in. Avalanche effect. When the two input values are similar, a hash function must generate significantly different hash values for these two inputs. This improves the security as it makes it very difficult to guess the input data by looking at the hash values. Collision resistant. For given two inputs, when a hash function generates an identical hash value, it is called a collision. A good hash function must minimize this possibility. Fast. A hash function should be efficient enough to generate a hash value quickly, even for a large input value. Here is a quick summary of the points covered. Hash tables manage data using the key value pair. Each key is sent to a hash function which generates a hash value. This hash value is then used to compute the index of a bucket or slots where the value is stored or retrieved. In case of password storage, an application takes a plain text password and pass it on to a hash function. The corresponding hash value is then stored in a database. And at the time of login, a user types in the password in plain text, which is again then passed to the hash function. And the newly generated hash value is compared against the one in database. With this, I wrap up the first video on hashing. So far, we learned about the definition of hashing. We learned about the characteristics of a hash function and a couple of applications of hashing. In the next video, we will implement a hash function and understand the concept of collision in a hash function. We'll also see common hash algorithms that are available with us and how we can use them in our programs. Thank you very much. Keep learning.